Good morning, students. This is Anjali, Assistant Professor at Department of CSE AIML, IARE, Hyderabad. Today's our topic is confidence interval. First, we will cover the previous topic, just a sampling. In last class, we have seen that introduction of sampling distribution, how does sampling distribution work, and central limit theorem. Sampling distribution. What is meant by sampling distribution? Sampling distribution is the probability distribution. It is your probability distribution of the statistics where you are selecting random samples. You are selecting random samples from the population. That means you are selecting the random sample from the given population, and on that basis there are some factors like a sample size, mean, variance. These are some factors of the sampling distribution. That means sampling distributions are totally depends on sample size, mean, standard deviation, again variance, and these are very helpful for calculating the mean, median, standard deviation. And when you are learning about the sampling distribution, it will work according to your population size, according to your sample size. That means first there is need to select your random sample with the specific size. Then after that you can calculate the statistics. That means you can find out mean, then standard deviation, median, you can find out. After finding, this is your first step. In first step, you have to select your random sample with specific size. Then you can calculate the mean, standard deviation. Then you have to develop the frequency distribution. And after that, fourth one, you have to plot the frequency distribution. Then we have seen that the central limit theorem. The central limit theorem is totally depends on your mean of the statistics. And these mean are totally depends on your sample size. And obviously, population and sample size both are related to your statistics. Population is it's a large group, and sample is your specific group from the population where you will select the particular size of the people. So this is all about the sampling distribution, its working of sampling distribution, and central limit theorem. Now we will start the confidence interval. First, we will see the contents. We are covering what is confidence interval, how to interpret confidence interval for effect size, then avoid a misinterpretation of the confidence interval, then confidence interval formula, confidence intervals versus confidence levels, and the confidence interval for a sample, just overview. Now, what is confidence interval? A confidence interval is a range of value that is likely to contain a value of unknown population parameter. In statistics, we are using the population parameter continuously for every sampling. For everything, here also we are using the population parameter for finding out some range of the values. and that range of the values are generally contain the some value, and that values are mostly unknown population parameters. And these intervals represent the plausible domain for parameter given the characteristics of your sample data. This confidence interval are derived from the sample statistics and the calculated using the specified confidence interval. In last class, we have seen the confidence level. So on that basis, it depends on you which confidence level you have to use. If you want to use 95%, if you want to use 99.7%, it totally depends on you which confidence level you have to use. That means on that level, your confidence interval result are depends. And population parameter generally unknown because it is usually totally impossible to measure the entire population. Obviously, we can't go to every person and we can't take the result from everyone. So it's not possible. So that is a large group. So that is our population. And by using the sample, you can estimate these parameters. Sample means you are using the simple and specific things. So you can estimate easily your parameters, whatever you want. These estimates are generally rarely equal to your parameters, and fortunately, inferential statistics procedures can evaluate a sample and incorporate the uncertainty inherent when using the samples. Then confidence intervals place margin error around the point estimate to help us understand how wrong the estimate might be. That means confidence interval can find out margin of the error according to your population, according to your result, and it will help to understand how wrong the estimate should be. And you will frequently use the confidence interval for binding the sample mean and standard deviation parameters. But you can also create them for regression coefficient, then proportion, rate of the occurrence, and differences between the population. So the confidence interval is a long run probability that the series confidence interval will contain the true value of the population parameter. Your population parameter is containing the true value. And these different random sample drawn from same population are likely produce the slightly different intervals. That intervals is suggesting the range. Intervals is suggesting range. If you draw many random sample and calculate the confidence interval for each sample, percentage of them will contain some parameter. But the confidence interval is the percentage of the interval that contain the parameter. And confidence level generally, mostly we will use the 95%, and the 95% confidence interval, an average of 19 out of 20, calculate the population parameter as shown below. You can see that this we will not consider. So, but we are considering. So, this is your population parameter, and 19 we are considering. So, this is 95% confidence interval, which is showing in that diagram. And the confidence interval procedure generally provides some meaningful estimates, because when we have to calculate, when we have to produce the range that contain some parameters, and they present some plausible values for the particular parameter. And technically, when you have to create the confidence interval using confidence level between 0 to 100%, the most common confidence level is a 95%, and analyst occasionally we can use a 99% and a 90% also. But most common confidence level is your 95%. Now, how to interpret the confidence intervals? The proper interpretation of the confidence interval is probably the most challenging aspect of this statistical concept. That means this is very important, how to interpret the confidence interval, because we know that the how to find out the confidence level and all, but we have to interpret the confidence interval. Just for this purpose, we will take the one example. Most common interpretation of the concept is there is a 95% probability that in the future the true value of the population parameter, for example mean, will fall within the x. That means x is your lower bound and y is your upper bound. That means we are finding out the population parameter within the x and y interval. And in addition, we may interpret the confidence interval using the statement below. So we 95% are confident that the interval between the x and y contain the true value of the population parameter. That means we are confident that the values will be available between the x and y only. This is your from the population parameter. But however, it would be inappropriate to the statement following. There is a 95% probability that interval between the x and y contain the true value of population parameter, and the statement is saying that it's showing that misconception about the confidence interval. And after statistical interval is calculated, interval can only be either contain population parameter or not. The interval may vary according to your sample, while the population parameter is same regardless of the sample. We know that if we have a population parameter, we can take number of sample from the same parameter, and that sample size can change. So the probability statement regarding the confidence level can be made. In this case, confidence interval are recalculated for the number of the samples. Now, how to calculate? The interval is calculated using the following step. First, you have to gather the sample data. First step is you have to gather the sample data from the population. Then after gathering the data, you have to calculate the sample mean, that is denoting x bar. Then determine whether population standard deviation is known or unknown. If it's unknown, then it's better. If it's not unknown, that means if it's known population, so you have to convert into the unknown parameter. If population standard deviation is known, we can use the z-score for the corresponding confidence level. But if your population standard deviation is unknown, this is about the known. If there is a standard deviation known, so you can use z-score. But if there is a standard deviation is unknown, so we can use to t-statistic for the corresponding confidence interval. And then after that, you have to find the lower and upper bounds of the confidence interval using the steps, using the formula. So known population standard deviation, when you are using the known population standard deviation, so there are two formulas. Lower bound is equal to x bar minus z into sigma divided by under root of the number of observation. These are your number of observation. This is your standard deviation. This is your mean. Then upper bound also x bar plus z into sigma divide by under root of number of observation. If you have a unknown population standard deviation, then lower bound is equal to x bar minus t as divide by root unknown. Here unknown standard deviation. Then upper bound x bar plus t into s root n. So confidence interval for effect sizes. Now confidence intervals are similarly helpful for understanding the effect size. For example, if you access a treatment and control group, the mean difference between this group is estimated that effect size. A two-sample t-test can construct the confidence interval for the mean difference. In this scenario, consider the both size and precision of the estimated effect. And ideally, the estimated effect is both large enough to be meaningful and sufficiently precise for you to trust. Now, confidence interval allow you to access both of these consideration. So, avoid a common vision, common misinterpretation of the confidence interval. A frequent misuse is applying confidence intervals to distribution of the sample values. For this, you have to keep in mind these ranges are generally applied only to the population parameter, not on the data values. These values, these ranges can apply on only population parameter. For example, 95 we have 95% confidence interval for 10 to 15. Range is a 10 to 15. That indicates that we can be 95% confident that the parameter is within the range of 10 to 15. However, it does not indicate that the 95% of the sample values occur in that range. It's not showing that. It's showing that only the range, that value can be available between the range 10 to 15. If you need to use your sample to find the proportion of the data to fall within the range, use the tolerance interval instead. You can use the tolerance interval instead of the confidence level. Now, what affects the width of the confidence interval? It will affect on the sample size, then variability and confidence level. They affects on the width of the confidence interval. But for this purpose, we will see one by one. First, sample variability. This variability present in your data, and it will affect on your precision of the estimate. Your confidence interval will be broader when your sample standard deviation is high. And it makes sense when you will think about it, and when there is a lot of variability present in your sample, you are going to be less sure about the estimate it produced. Then, after all, high standard deviation means your sample data are bouncing around, and that's not the conducive for the finding precise estimate. Unfortunately, you often don't have much control over the data variability, and you can institute the measurement and data collection procedures that reduce the outside sources of variability, but after that you are the mercy of the variability inherent in your subject area. But if you can reduce the external sources of variation, that help you to reduce the weight of your confidence interval. This is about the sample variability. That means it will affect on the weights of the confidence interval. Now, sample size. Increasing your sample size is primary way for reducing the width confidence interval. Why we are saying that if you will increase the sample size, your confidence interval weight will be decreased. You can control it more than the variability. Variability, it's not in our hand, but sample size is in our hand. So we can keep control on the confidence intervals width. If you don't change the anything else and you only increase the sample size, the ranges tends to narrow. But need even tighter confidence interval, just increase the sample size some more. And now you observe, there is no limit and you can dramatically increase the sample size for producing the narrow ranges. That means sample size in our hand, so we can control on the sample size, but on the variability, we can't control. And logistic, time and cost issue can constrain your maximum sample size in real world. And larger sample size, lower variability reduces the margin of error which is available in the point estimate, and where we have created the narrow confidence interval. And these factors are very important in the confidence interval. So, sample variability, it's it's not in our hand, but sample size is in our hand, so we can control on it. Then changing the confidence level. The confidence level generally affects on the confidence interval width. We have already seen that. But factor is methodology choice separate from the your sample characteristics. If you increase confidence interval, just we can take that uh, example as a 95% to 99%. First, we have confidence interval 95%, and now we have increased that from 95 to 99%, while holding the sample size and variability constant. Now, your confidence interval widens. But conversely, decreasing the confidence level. Now, what you have done, you have decreases your confidence level from 95% to 90%. That means you are doing you are narrowing your range. Now, we have found that the effect of changing the confidence level on the width of the range to be counterintuitive. It depends on the situation how you are increasing and decreasing the confidence level, and according to this your confidence interval width is changing. So imagine you take your knowledge of the subject area and indicates you are 95% confident that the correct answer lies between the 59 and 20. Now you have to give me your confidence for it falling between the 17 and 18. And correct answer is to fall within the narrower interval, so your confidence naturally will be decreased. Now I am asking you about your confidence that it's between 10 and 30. That's much wider range. You know that 10 and 30, this is wider range, and correct value is more likely to be in it. So your confidence will grow. But confidence level involve the trade-off between the confidence and the interval spread. And to have more confidence that parameter falls within the interval, you must widen your interval, and your confidence necessarily decreases if you use the narrower range. Now we will see the confidence intervals formula. Confidence interval accounting for the sampling uncertainty by using the critical values, sampling distribution and standard errors. And this formula totally depends on the type of the parameter you are evaluating. Most common type is for the mean. So we will use again mean only. You will use the critical z values or t values for calculating the confidence interval. And t values generally produce accurate confidence interval when you do not know the population standard deviation. We have already seen that for unknown population, unknown standard deviation, we have to use a t-score. That's particularly true for sample sizes smaller than 30. And for larger samples, the two methods produce similar results, and you will use their generally t-value. So there are two formula where we are using the both z-score, z-value and a t-value. Confidence interval x bar plus minus z plus s divided by square root of n. That means x bar is your mean, z is a z-score, s is your standard deviation, and n is your number of observation. Number of observation, not a number of particular number of observation. It is your standard error of the mean. Error of the mean. Again, here we will use the z-score value, and here we are using the t value. So x bar is your mean, which is the point estimate. Z is a critical z value. T is a critical t value. Then s is a sample standard deviation, and s divided by square root of n means standard error of the mean. Now the only difference between the two formula is the critical value. If you are using the critical Z value, then definitely you will always use 1.96 for 95% confidence interval. For every confidence level, you have a Z value. It's a default value, so you can use directly. And for T value, you will need to know the degrees of the freedom. So then you will look up for the critical value in the T table or online calculator. For calculating the confidence interval, first you have to take the critical value Z or T, and then you have to multiply it by the standard error of the mean, and this is your margin of the error. And then add and subtract the margin of the error from the sample mean for producing the upper and lower limit of the range. Now the question is that in a tree, there are 100 of mangoes. You randomly choose the 40 mangoes with mean of the 80 and a standard deviation of 4.3. Now you have to determine that the mangoes are big enough. We have a mean 80, standard deviation 4.3 and number of observation are 40. So here we will take the confidence level as a 95%. So therefore our Z value will be 1.9, or we can say that 1.96. There is no need to calculate the Z value. We know that these values are available with particular confidence level. For particular confidence level, there is a different Z value. So after that, you have to keep all these things in the formula. And when you will keep all these value in the formula, you will get the answer as a 80 plus minus 1.33. So the margin error is 1.33. And all the 100 mangoes are likely to be in the range of the 78.67 to 81.33. Now the Z value. The Z is the number of standard deviation from the sample mean. And our sample 1.96 for 95% confidence and 2.576 for 99%. And Z score can be positive or negative, and this sign tells you whether the observation is above or below the mean. And for example, Z score of +1 shows that data point falls one standard deviation above the mean, and while -1 signifies that standard deviation below the mean, and Z score of the 0 equals the mean. And how are the confidence interval used? Generally, statisticians use the confidence interval for measuring the uncertainty in the sample variable. And for instance, a researchers may randomly select different sample from same population, and they can compute the confidence interval for each sample for determining how will it represent the actual value of the population. And the resulting data set are all different, and with some interval it will included and others not including the true population parameter. Now you can see that this is the confidence interval. This is showing on a y-axis, it's showing the density, and this is your x. These are showing the -1.96 to 1.96, and the normal curve, it is your normal curve where mean is a 0, standard deviation is mean, and the shaded area is 0.95, means 95% confidence level. After that, what is t-test? Statistically, methods such as t-test are used to calculate the confidence interval. This t-test is identical statistic used to observe significant difference in the average of two groups that could be linked to specific characteristics. There are three fundamental data values are required for calculating a t-state, and these are including the mean difference, that means the difference between the mean values in each data set, standard deviation of each group, and the data points in each group. These three values we have to find out. Then confidence interval versus confidence level. Confidence levels are expressed as percentage. For example, 95%, 99%. It means that should you repeat the experiment or survey over and over again, 95% of time your result will match the result you get from the population. And the confidence interval are your result, and they are usually numbers. For example, you survey a group of pet owners to see of dog, how many cans of dog food they purchase a year. This will show the number, so it is the confidence interval. Now you test your statistic at 99% confidence level and get a confidence interval of 200 300. That means you think they buy between 200 and 300 cans a year. You are super confident that 99% is a very high level, that your result are sound statistically. That means here we are seeing that the confidence interval, and this is 95% is your confidence level. This is your upper limit and this is your lower limit. Upper limit and lower limit are 0.025 and this is your mean. Now, confidence interval for a sample. When you don't know anything about the population behavior, you need to use the T distribution to find the confidence interval. That means if you are unknown for the population, you are unknown for population behavior, then you have to use the T distribution. It's a very vast case where you usually don't know the population parameter. Otherwise, you know you will get idea about the known parameters, and the confidence interval generally tells you how confident you are in your result. With any survey or experiment, you are never 100% sure that your result could be repeated. If you are 95% sure, 98% sure, then that's usually considered good enough in the statistic, and that percentage of the sureness is your confidence interval. In today's session, we have seen that the confidence interval and relation between the confidence level and the confidence interval. This is all about the confidence interval. So these are your references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.